Hi everyone, welcome to Crystal Clear Chemistry channel. In this video, I am going to discuss about 25 questions of chemistry of JEE mains level. This is my second model paper of mains. Like this, I have already uploaded even the NEET and the NSET level model papers. Please go through the video. If you really like the video and if you feel that it is very helpful, please like, share and subscribe to my channel. Without any delay, let's get into the question now. The first question, the KH value for argon, CO2, HCHO and methane are given respectively at a given temperature and pressure. Arrange these gases in the order of increasing solubility they are asking. Here, Henry's constant KH, if we consider, it is always inversely proportional to the solubility, right? Henry's constant KH is always inversely proportional to the solubility. Higher the KH value, lesser will be the solubility. Based on this, you can easily find out the increasing order. In the given values, the highest one is 40.39. After that, 1.67 follows. Next, 0.1413 and then this 1.83 into 10 power minus 5. So based on this 40.39 is for argon, right? So if you compare these values, you will get the answer as C. Next one. Using the data given below, find out the strongest reducing agent. Strongest reducing agent they are asking. The one which readily undergo oxidation. The ion or atom, whatever it may be, which readily undergo oxidation will act as a reducing agent. Here, if we consider the ions or atoms, this particular E naught values, if we consider SRP values, lesser the SRP value, more easily undergo oxidation. So, lower SRP value atom or ion readily undergo oxidation. Here, if we consider the chromium, it has a negative SRP value. That means it readily undergo oxidation. It is the strongest reducing agent. So, based on this point, we can say the answer is B. Let's move to the next one. Consider the following figure and mark the correct option. Here, if you observe the graph, this is the energy and this is the reaction coordinates, reactants and products. Reactants gives rise to products here. The reactants, after getting the E1 plus E2 energy, only it converts into activated complex, then only it is converting into products. And if you observe the energy of these reactants and the energy of the products having the higher energy, what does it indicate? It indicates that the reaction is endothermic reaction. The reaction is endothermic reaction. Anyhow, let's get into the options now. The activation energy of the forward reaction is E1 plus E2. Yes, this is the forward reaction and this is the total energy of activation for forward E1 plus E2. And here they have said that the product is less stable than reactant. Product having the higher energy when compared to reactants. Higher the energy, lesser is the stability, right? Higher the energy, lesser is the stability. So based on this, we can easily conclude that the first one itself is the answer and you can go through the remaining also later. But for this question, the option A is the correct one. Let's get into the next question. Consider a first order gas phase decomposition reaction given below. The initial pressure of the system before decomposition of A was Pi. After the lapse of time t, the total pressure of the system is increased by x units and became Pt. So the rate constant K for this reaction is, it's a first order reaction we know. So suppose if we consider A gives B plus C Let Pi is the initial reaction, initial pressure. When Pi is reduced by X units, then X units of B, X units of C will be increased, and the total reaction, if we consider the total pressure, if we consider, it will be Pi minus X plus X plus X. X gets cancelled, so Pi minus Pi plus X is the after the lapse of time t. That means this is Pt. Then what will be the X value here? Pt minus Pi. So remember this value, X is equal to Pt minus Pi. Now they are asking for the rate constant of K. We know the rate constant for first order 2.303 by T into log A by A minus X, right? That is equal to 2.303 by T into log, what is A? Initial one, Pi, divided by, what is A again? Pi, minus, what is X here? Pt minus of Pi. So Pt minus of Pi, right? So minus of minus plus, and there is 2Pi, and for Pt we get a negative value here. So the probably the fourth one, 2.303 by T into log Pi by, it's not the fourth one. Let me check. Yes, this B is the correct option. See, Pi divided by 2Pi minus Pt is the expression for the rate constant of this gas phase decomposition. Next one. Metallic radii of some D block elements are given below. Which element has the highest density? If you look at the metallic radii, there is a slight increase in the atomic radius from copper to zinc, but anyhow the copper will have the highest density in the given elements. Next one. Gadolinium belongs to 4F series. Its atomic number is 64. And which of the following is the correct electronic configuration of gadolinium? See, this is a factual question. And if you look at this particular xenon 4F75D1 6S2, this is the anomalous configuration of gadolinium where it gets a half-filled F subshell, right? Next one. The color of the coordination compounds depends upon the crystal field splitting. What will be the correct order of absorption of wavelength of the light in visible region for the complexes? For this type of questions, we need to look at the strength of the ligand. Stronger the ligand, more is the energy that absorbs, then lesser will be the wavelength. But here they're asking for the wavelength order, the decreasing order. That means the one which is a weak ligand will be having more wavelength, right? So based on this point, if you check the ligand strength, the Cn minus ion is stronger than NH3 compared with the H2O. So the correct option will be C. Let's move to the next one. Arrange the following compounds in the increasing order of rate of reaction towards nucleophilic substitution reaction. If we consider electrophilic substitution reaction, um, electrophilic substitution reactions are directly proportional to the electron releasing groups. Electron releasing groups increases the electrophilic substitution reactions reactivity of the compound, whereas electron withdrawing groups readily increases the nucleophilic substitution reactions. Nucleophilic substitution reactions. If we consider these halobenzenes, halobenzenes reactivity increases by the electron withdrawing group like NO2. In that case, which is more reactive? Definitely, as it is nearer to the chlorine, it is more reactive. Next is C, next is A. So the answer will be B, C, A. Increasing order A less than C less than B. Next one. Mark the following order of decreasing acidic strength of the following. They have given different substituted phenols here. So this is nitro group, methoxy group, nitro group and methoxy group. They are asking for the acidic strength, right? Now, how to check the acidic strength for this type of questions is the one which readily liberates the H plus ion will readily form a phenoxide ion, will readily form phenoxide ion. This phenoxide ion is stabilized by electron withdrawing group. It is stabilized by electron withdrawing group. So, those phenol substituent compounds which are having the electron withdrawing groups are more acidic when compared with the others. So, if we consider the electron withdrawing nature, definitely NO2 is having that more electron withdrawing nature. So, NO2 and here also NO2 is there. In fact, this NO2 can exhibit both minus I effect as well as minus R effect, which are favorable for the acidic strength. That is the reason why B is more acidic than D. Then among these three, which is more acidic means, suppose if we consider this particular OCH3 at meta position, the methoxy group at meta position can only show minus I effect. Though it is plus R, it will not show plus R effect when it is at a meta position. So minus I also the favorable factor, though it is a plus R group. So we can say that C is having the higher acidic strength when compared with the benzene, phenol. And at the end, if we consider this OCH3, though it is having that minus I effect because of the dominating plus R effect, it destabilizes the phenoxide ion, hence less acidic in nature. So what will be the correct answer? The C1 is the correct answer. Let's get into the next one. The reagent which does not react with both acetone and benzaldehyde is aromatic aldehydes and ketones. They do not respond for Fehling solution, right? So the answer is C. Next one. Addition of water to alkynes occur in acidic medium and in the presence of Hg plus 2 ion as a catalyst. Which of the following will be formed as a major product on the addition of water to but1-ine? So let me write the but1-ine first. CH3, CH2, C triple bond CH is but1-ine. And here on mercuration and deoxymercuration, HgSO4 and H2SO4, immediately what will happen? At unsaturated positions, water molecule will be added, and we know OH and H will be added here after removing one bond here. For further removing, further elimination, for further addition, again OH here and H here. Whenever two hydroxy groups are there, water molecule will be eliminated so that you will get a double bond here. So at the second position, double bond, that means methyl ketones will be formed. That is the reason why the B is the correct one. Next, which is the most suitable reagent for the following conversion? Uh, Following conversion, what happened here? COCH3 converted to COOH. As soon as we look at that methyl ketone, we should know about that iodoform reaction where it readily reacts with NaOH to form iodoform CHI3. Along with this yellow color precipitate of iodoform, sodium salt of carboxylic acid will be formed. So on hydrolysis you will get the carboxylic acid again. So that means the better option is this I2NaOH. Next one. Among the given set of reactants, the most appropriate for preparing secondary amine is secondary amines. Let's check once. So, and H2RCHO. There is a possibility of condensation reaction followed by hydrogenation. Definitely, we will get a secondary amine. Let us see how it is. RNH2 plus RCHO. Here both H2 and O will be eliminated, right? And you will get Rn double bond CHR. There is a double bond between N and C here. On hydrogenation, definitely this bond will break. This bond breaks, and here you will get a hydrogen. In this here you will get a hydrogen. So RNH CH2R, which is a secondary amine, right? So easily we can get the secondary amine by this option C. Dinucleotide is obtained by joining two nucleotides together by phosphodiester linkage. Between which carbon atoms of the pentose sugars of nucleotides these linkages are present. So if we consider the dinucleotide, the dinucleotide is obtained by joining two nucleotides, no doubt, and they are joined together by phosphodiester, and that linkage is between the 5' and 3' carbon atoms of the pentose sugar. It's a factual question, so the answer is A. Next one. Polarity in a molecule and the dipole moment depends primarily on electronegativity of the substituent atoms and the shape of the molecule. Which of the following molecule has the highest dipole moment? Yes, no doubt. Dipole moment depends both on electronegativity and the shape of the molecule. If the electronegativity difference is high, the dipole moment will be high, and the symmetrical molecules will have usually the zero dipole moment. There are few exceptional cases that we will discuss when that type of bit we come across. Anyhow, here in the options, the electronegativity difference between O and H is more. So the correct option is C. Next one. The entropy change can be calculated by using the expression delta S is equal to Q by T. When water freezes in a glass beaker, choose the correct statement among the following. Yes, if we consider the freezing in fact is an exothermic reaction. Yes, it is an exothermic reaction. Within the system, no doubt, as the water freezes, the delta S decreases as the randomness decreases here. But what happens to the surroundings? The entropy difference here, the entropy difference decreases, and here also the randomness increases for the surroundings. That is the reason why the correct option is C. Next one. Using the standard electrode potential, find out the pair between which the redox reaction is not feasible. Redox reaction is not feasible. Whenever delta G is negative, then the reaction is feasible. Suppose if we consider delta G, it is nothing but minus NFE naught of the cell. If E naught cell is greater than 0, then we can say that the reaction, the cell reaction, redox reaction is spontaneous. But in some, if we consider these combinations and all, let's check the combinations first. So Fe plus 3 and I minus, if we consider, it is nothing but 0.77 minus 0.54, which is a positive value. So it's a feasible. Ag plus and Cu, 0.8 minus 0.34, it is also feasible. Fe plus 3 and Cu, 0.77 minus 0.34, no doubt it is also possible. And what about Ag and Fe plus 3? Ag is 0.8 and Fe plus 3 is having a 0.77. Yes, no doubt it is having is showing the difference as plus, but as they are almost same, there is no much positive value for the E naught. That is the reason why we can say that the least possibility, the least feasibility is for this Ag and Fe plus 3. The one which is having the higher difference between the E naught values will readily exhibit that redox reaction. So whenever if they ask the reactivity order also, we can check based on the positive E naught value of the cell constructed by these options, right? Let's get into the next one. The correct IUPAC name of the following alkane is. The correct IUPAC name of the following alkane is. So they here we have branches also in the compound. Let's start. Take the longest chain from here. 1, 2, 3, 4, 5, 6, 7, 8. So it's an octane, substituted octane. This is one ethyl group and this is another ethyl group and this is the methyl group, right? So ethyl comes in the alphabetical order, which is 3, 6 diethyl, and the second carbon methyl group is there, so 2 methyl octane. So the first one is the correct one. Next, a first order reaction is 50% completed in 20 minutes at 27 degrees centigrade and 5 minutes at 47 degrees centigrade. They are asking us to calculate the energy of activation of the reaction. Here, if we consider the K value, K is equal to 0.693 by T half, right? So, if we substitute at different temperatures of these two values, one is at K1, the other which is at the temperature T1, and next K2, which is at the temperature T2, then you will get K1 and K2 values. After getting the K1 and K2 values, how to calculate the EA value, right? EA value. How to calculate the EA value? See, we have the formula. Log K2 by K1 is equal to EA by 2.303 into R into 1 by T1 minus 1 by T2, right? So first we need to calculate K1 and K2. Then we need to substitute those terms in this equation in order to get the EA value. And R value you have to take 8.314, where you get the value in terms of joules and you have to convert that into kilojoules. If you substitute 300 Kelvin as T1 and here 273 plus 47, 320 Kelvin as a T2, you will definitely get the EA value as 55.14. Next one. In which of the following compounds chromium has highest oxidation state? This one if we consider X plus 8 into minus uh, this CrO8 minus 3, right? One second. The CrO3 minus 8, all the oxygens are having that peroxide linkage. See, CrO8 minus if we consider, the structure will be like this. Mm, Cr, one O and this another O. Next, the remaining oxygen O minus ions are like this. So all are peroxy bonds. That is the reason why we need to substitute 8 into minus 1 is equal to minus 3, where you will get X as a plus 5 for chromium here. And it is just NH4 twice Cr2O7. NH4 means plus 1 oxidation state. So 2 into 2x minus 14 is equal to 0, where you are getting X as 6 for chromium, the regular oxidation state. But if you consider CrO5 again, CrO5 the structure is like this. This is the CrO5 structure where you are getting 4 oxygens are in the peroxy bond. So X plus 4 into minus 1 plus 1 into minus 2 is equal to 0. X you will get as 6. So if we consider that the plus 6 configuration is in both B and C, hence the answer is D. A mixture contains methane and ethylene in the volume ratio X is to Y. Has a little total volume, sorry, a mixture of methane and ethylene in the volume ratio X is to Y has a total volume of 30 ml. So methane, nothing but CH4, ethylene, nothing but C2H4. They have the total volume of 30 ml in the X is to Y ratio. Okay. On complete combustion, it gave 40 ml of CO2. If the ratio had been Y is to X instead of X is to Y, then what is the volume of CO2 would have been obtained under the same temperature and pressure. First, till here, let us do the calculations and all. So, CH4 undergo combustion readily gives CO2 plus 2H2O, right? CO2 plus 2H2O. And here there are 2 moles, 2 moles. Um, how many moles of methane? As it is in the ratio of X is to Y, let us suppose that X moles, X ml we have taken. So that X ml of carbon dioxide will be formed. Next, ethylene. C2H4 plus again O2 gives rise to 2CO2 plus 2H2O this time. Total of 6 oxygens. So here you can write 3, sorry, yeah, 3 you can write. So anyhow, how much amount of CO2 will be liberated if it is a YML? You can go with this 2 YML, right? Now, they are saying that this mixture they have taken as a 30 ml. So that means X plus Y is equal to 30 ml. Next, on complete combustion gave 40 ml of CO2. CO2, how much is produced here according to our calculations? X plus 2Y. So X plus 2Y, nothing but 40 ml. Um, by solving these two equations, for example, if we substitute instead of X as 30 minus Y, this equation becomes 30 minus Y plus 2Y is equal to 40. 30 plus Y is equal to 40 implies Y is equal to 10 ml. If Y is equal to 10 ml, X will be 20 ml, right? But what they are saying, instead of taking as X is to Y, if Y is to X, if they take, what does it mean? This time, XML is produced. Instead of XML, if we take YML of methane, that means this time for CH4 we have to take YML, that means 10 ml, so that it produces 10 ml of CO2. But C2H4 we have to take XML, so that means 20 ml C2H4 we have to take. 20 ml readily produces how much amount of CO2? Twice the amount, right? So 40 ml. Then they are asking for the here. They are asking for the what volume of CO2 would have been obtained. So how much is produced? 10 plus 40. Total 50 ml is obtained. 50 ml of CO2 is obtained. Right? 50 ml of CO2. Let's move to the next one. To which quantum level does the electron jump in a hydrogen atom from the lowest level? If it is given an energy corresponding to 99% of ionization potential. Once again, if the hydrogen atom is given some amount of energy, how much energy? 99.99% of ionization potential. Ionization potential of hydrogen is 13.6 electron volts, right? So 99% of 13.6 if we give, then if it they're asking for the to which quantum level the electron jumps, right? So according to the Bohr's equation, Bohr's theory, delta E is equal to E2 minus E1. Okay. How much energy we have provided? 99.9 99% and then 99 by 100 into 13.6. E2 minus E1. How to calculate the energies of the orbitals in terms of electron volts? We know that it is minus 13.6 into 1 by N2 square minus of minus 13.6 into 1 by N1 square. E1 is nothing but here the lowest energy level, that is the first state, first orbit. So if we substitute 1 in presence of N1, we get only 13.6 plus 13.6 we get. This implies minus 13.6 into 1 by N2 square plus 13.6 is equal to how much? 99 by 100 into 13.6, right? It's not implies this is equal to. Okay, this implies minus 13.6 into 1 by n2 square is equal to how much? 13.6 if it comes this side, 13.6 will be there. So here after getting the LCM and 13.6 as a common, you will get 99 minus 100. So here you will get minus 1, minus minus cancel. So that what is the net equation here? Minus 13.6 into 1 by n2 square is equal to 1 by 100 into, sorry, it's plus 13.6. So 13.6, 13.6 gets cancelled and n2 you will get as a 10, right? So to the 10th energy level, the electron jumps. Let's move to the next one. Equivalent conductances they have given, and they're asking us to calculate the approximate value of equivalent conductance of the Na2SO4 at the same dilution. Nearest integer they are asking for. So if they give molar conductances, we have to take the valencies also. But for equivalent conductances, no need to take the valencies. In fact, they are asking for Na2SO4 means uh, equivalent conductance of Na2SO4 will be given by equivalent conductance of Na plus equivalent conductance of SO4. And here equivalent conductance of these two ions we need to add, but directly we don't have the values. So what we need to do? We have to add NaCl plus K2SO4, and then we need to subtract KCl from this. All are equivalent conductances. So here we are getting 126.5 plus 153.3 minus 149.9. Approximately you will get the value as 129.9. That means 130. We have to write as an integer answer. Right? Next one. Number of moles of CH3MgBr which will react with 1 mole of the compound Y to get Z. Here, here first let us see the what and all changes had happened from Y to Z. Okay, so here CH and CH is there. No change, but this is an acidic hydrogen terminal alkyl. OH and here also OH. Next, the CH2 CHO turns into this tertiary alcohol. The COCH3 ester turns into alcohol group, and again here the cyanide converts into the keto group. Right? Now let us see one by one. If we consider this CH triple bond C, definitely it consumes one CH3 MgBr as it is an acidic hydrogen. It readily attack on the CH3 minus, which is a carbon ion from the Greek North reagent, and you will get a CH4. And here the CHOH, though it converts into OH again, but still it first reacts with CH3MgBr and readily converts into CHOMgBr. Wherever the acidic hydrogens are there, there the magnesium bromide readily replaces the hydrogen. MgBr, not magnesium bromide, MgBr readily replaces. After the hydrolysis, again we will get this one, no problem about that. But consuming of number of moles of Grignard's reagent they are asking for. That's the reason why we are checking all the things. And here ester group is there. Ester readily requires 2 moles of Grignard's reagent, and the cyanide to COCH3 also requires 1 Grignard's reagent. So 1 plus 2 plus 1, 4, and here 5, and then here 6. So for this the answer is 6 moles of Grignard's reagent or MgX are required uh, for 1 mole of the compound Y to get the Z. Right? Next one. The number of alkenes possible of the molecular formula C6H1, which give two different products on ozonolysis, out of which only one gives a iodoform test. We have to write the different chain position isomers of this hexene, but there are two conditions here. On ozonolysis, it should give different products. This is the first condition. So it's a bit lengthy process to check all the things. Anyhow, I'm going to write the answer here, direct answer. First of all, there are five alkenes which satisfy both the conditions. The first one is CH3, CH double bond CH, CH2 twice CH3. The second one CH3, CH double bond CH, next CH, CH3, CH3. Next, third one CH3, C, CH3, double bond CH, CH2, CH3. Fourth one CH2 double bond C, CH3, CH2 twice CH3. The last one is CH2 double bond C, CH3, CH. Uh, here CH, CH3 must be there. CH, CH. CH3, CH2, symmetrical alkenes, for example. But CH, double bond CH, CH2, CH3. On ozonolysis is giving the same product. So we can't consider this alkene, right? So it's a bit lengthy process to answer this question. But anyhow, we are getting 5, so the 5 is the answer. That's all for today. I hope this video reaches many. All the best.